Okay, continuing the notes on what is this? You're changing the radicals to exponents, right? So we said like the 6th root of x, right? Because now I'm recording this is in the video, right? We know that this is going to be what? Now you got to remember this is going to be a fraction, but this here is your denominator. See, the 6 is the denominator, and then there's no other numbers here, so it's 1 6. You guys get that? Yeah. Okay, but now you're going to have something like this. What if it has like, here's number 1. How about if it has number 2 like this? A to the power of 2/3. Well, you got to learn to kind of split this up. You got to split this up, and you got to see which one's the number that's the fraction. Which one's the fraction, you guys? The 2 or the 3? The 3. The 3. So I want to see it like this. I want to see that if it's the 3, then it's like, gosh, how can I tell you this? This is like A2 times 1/3. It's like you're splitting the 2/3 up. Do you guys agree 2 is 2 over 1 times 1 over 3, like that? Okay. So, long story short, you want to, out of this 2/3, you want to kind of look at just a fraction, which is just the 1/3, and you want to see that separate, right? So really this is, I really didn't want to go here, but it's really a squared, and you just want to write the 1/3 like this. See, pull out the 1/3 out to the top, and it's a squared, yes? Now, what does this 1/3 become? Hello? Hello? What does it mean when you have a rational exponent that it's a radical? You know, the square root looking thing? So this 1/3 is what? This 1/3 is your cubed root. See, this 1/3 is your cubed root, is this. And what goes in here? A square like this. You guys see that? Yeah. But there's another way that I noticed this worksheet doing it, and that's why I wanted to clarify it. This is correct. This is the way that I want you to do it. But I'm going to tell you what the worksheet also does. The worksheet does it like this. The worksheet separating this a different way. It's doing it like this, and it's not incorrect. It's not incorrect. Okay? I'm just going to give you the other answer, and I'm going to see if you can figure it out. The other answer is this. Okay, coming from here, right? We got this one. The other way to do it is they do the cubed root of A, right? Right, that's the cubed root of A, right, this one? And this squared, this other power, this is a whole number, right? This one, instead of putting it in here, they can also write it on the outside. You guys see it? Where this one, they kept the 2 and they kept it on the inside, and this is correct. Or, this is another way of also writing an equivalent form of this answer. And this is the part that I wanted to clarify, because I think some of you are seeing your answers like this. You're seeing your answers like this on the homework assignment from yesterday, bless you. But the way I taught it in the notes is like this. Okay, I'm going to do another one. Does that make sense? Okay, number 3. Check this out, number 3. X to the power of 4/5. Sorry, x to the power of 4/5. You know the 2 ways to write it? Okay. Does everybody agree and here I'm just going to do like a little split screen why it's like that. One of them is because they do x to the 1/5. Remember, you always want to see the fraction 1 over whatever the denominator is. And then the 4 like this. Or the other one is where they do x to the whole number is 4, and then they pull the fraction part out there. You see, they're just separating it differently. So how would you write this one? Well, 1/5 is what? The 5th root. This part with the parentheses right here is the 5th root of what? X. And what stays outside? The 4. See, this is the other way. This is not the way that I showed you, but this is the way that the worksheet's kind of showing the answers. I like it. So this is one way to write it. I like it this way, like this, where you just keep the power inside like this, and then the 1/5 is your 1/5 is this part, right? That fraction, the 1/5 or 1/3 or 1 or whatever, that's your radical. But the other number, which is the whole power, sometimes they can write it on the inside. See, this is x to the power of 4 and it's here. Or they'll write it out here on the outside. Everybody see this one's on the inside? And this one's on the what? Outside. They're both correct. But I'm just telling you, I think I'm showing you like this in the notes and in the video. But when you go look at the worksheet and the answers in the worksheet, it's looking like this on some of them. Okay, let's do one more like this. Let's say you tell me the two different forms for writing this. See, right now, is this an exponential form or is this in radical form? Oh, exponential. When you see an exponent in its exponential form. When you see something given to you with any kind of, the square root thing like this radical, that's how it's in radical form. Okay, so you're gonna convert this not to exponential form. It's already in exponential form. Convert this to radical form, but there's two ways to do it. Go ahead. Go ahead and do that. Okay. So what's the fraction? What's the fraction here? 1/9. See? Just put 1/9. 1 is everywhere. Isn't 7 times 1? So I know the fraction is 1/9. But actually, I actually did that wrong. I like to write the fraction on the outside. I like to put the radical on the outside, and then this would be y to the power of what? 7. Yeah? So this would be what? The 9th root of y to the power of 7. Okay, I like to write it like this. But what's another? Or who can tell me the other way to write it? Yeah, see, that's when you start seeing all these parentheses and all this other stuff, and it looks just crazier. Just remember that you have your 9th root of y, but this 7, instead of putting it in here, they put it where? Instead of it being in the inside, they put it out here on the outside. These two are saying the same thing, are really saying the same thing essentially. It's just that here, the 7, they wrote it on the inside, and here they take this and they just bump it out to the outside. That is the only difference. Does that make sense? Okay, just clarifying that. Both of these are correct. I think I'm teaching it like this in the video in the lesson that's there, but I think the worksheet sometimes shows it like this. Okay, next. Well, it's kind of really the same thing. Now look at this. What about this? Tell me, now we're going to go from radical to exponential form. Right in exponential. I mean, they shouldn't even have to tell you. Can somebody tell me why they shouldn't have to tell you? Here, let me show you the problem first. Number 1. I want you to tell me what's the difference between this one. I'm going to call this one 1A, and I'm going to call this one 1B. See, after this, you'll kind of see what I'm talking about. What is the difference between this one and this one? Oh, does everybody see why they have to tell you to write it in exponential form? Because it has a radical. If it has a radical, well, you're not going to write it in radical form. It already has it. So it's going to tell you to write it in exponential form. Okay. So you just got to remember you're working with exponents. You're changing it. You guys should be good with exponents. We just finished the positive exponents, negative exponents, and all that business. What is this, you guys? What is this? This is n to the power of what? 1/6, right? This part, isn't it n to the power of 1/6? But then you have this power raised to this power. Do you guys remember what happens when you have a power raised to... Oh, by the way, it was called the power rule. The power rule. That is when you multiply. So what happens when you multiply 5 times 1/6? You're going to get what? 5/6. I mean, if you really want to sit there and do all the steps, it'll be 1/6 times 5/1. Come on, right? Just remember, the 5 is the whole number that stays on top. The 5 is the whole number that stays on top. That's the numerator. The 6 is the denominator. It stays on the bottom. That's easy. You guys see it? So changing this radical to exponential form, the answer is n to the power of 5/6. Yes? Okay. Now tell me what's the difference between this one. Now let's do this one. Are you okay with 1a? Okay, now what are you going to tell me about this one? This is n to the 5. I see this n already has a 5. That's already an exponent. But what's going to be this part, this radical part? Isn't that going to be to the power of what? 1/6. Which number stays on the bottom and which one goes to the top? Okay, so do you guys agree that these two are the same? That's what I was telling you over here, see? Where one of them has the exponent on the inside and this one has it on the outside. That's what I just did here, look. Here, I put the 5 on the inside and here I put the 5 on the outside. But when you change it to exponential form, you get the same answer. You see, because it's saying the same thing. They could just write it in different forms. This one with the parentheses and all this craziness just looks more complicated. It's not. You guys understand that? Yeah. Yeah, go ahead. Let me give you another one. Here it goes. It's going to be the same deal, right? All right. So, how about this one? This is 2a and this is 2b. The fourth root of 2n all to the power of 3. And this is going to be the fourth root of 2n, but in the inside it's all to the power of 3. Okay. So this one is what? 2n to the power of what? 1/4? That's this part, the inside part, right? But when you have a power to a power, what is it going to end up being? 2n to the power of what? The 3 is the whole number, stays on top. The 4 is the denominator, stays on the bottom. It's 2n to the power of 3/4. Yeah? What about this one? Well, that's 2n to the power of 3. But then what happens to this fourth root? What happens to this part here with the fourth root? That turns into what? Like a 1/4 up here. It's just a power raised to another power. But essentially what's going to happen? The 4 is the denominator, it stays in the bottom, and the 3 is the whole number, it stays in the top. So what are you going to get? 2n to the power of what? 3 over 4. Sometimes they're going to write it like this. Sometimes they're going to write it like this, where the whole number is inside or where the whole number is outside. It doesn't matter. You just remember that whatever the number is for this radical, this thing right here, for the root, right here, that's going to be your denominator number. And this other one will be what? Your numerator, see? You guys see it? Same thing here. This one will go on the top. This one will go on the bottom. Yeah? Is that okay with that one? Okay, last one. What about this? 3a, 3b. What about 8x cubed like that? And that's it. And then this one will be what about that? What happens if it doesn't have a number right here, you guys? You got to know what it is. You have to know that. So you better write. If I were you, I would write it. 2, because you got to see it, right? And that's really going to be what? 8x. That's 3. And this other exponent is what? Not 2. It is what? 1/2. But long story short, when those exponents multiply, you know which number is going to stay on the bottom, and you know which number is going to stay on the top. Yeah? What is it going to be? 8x to what power? 3 over 2. Don't multiply 3 times 2, okay, and put 6 or something like that. Yeah, the 2 is in the bottom, and the 3 is in the top. So it's like, that is right. That is correct, like that. Okay. And then the same thing here. When your radical doesn't have a number, you better put a 2 right there. No, you got to see it, right? You got to see it. Okay? So what's this going to be? This is 8x to the power of 1/2. But then there's that other 3 out here, see? Right, because the power rule, power to another power, they multiply. Long story short, you know which one goes on top, you know which one goes on bottom. You're still going to get 8x, what? What's this rational exponent over here? 3 over 2. The 2 is the radical, that one stays on the bottom, the whole number stays on top, 3 over 2. See, it's the same thing. See, we're getting the same thing, see? What looks different is, you see, look at the way this problem looks, where this power is out here, and look at where this one, the power is in the inside. That's what I wanted to clarify. Okay. That was write it in an exponential form. Okay, now write each expression in what? Radical form? Kind of going back, because we kind of just did this a little while ago, but here's where you can give me the answer 2 different ways. So here's number 1. X to the power of 2/3. How would you write this in radical form? Well, like I said, the way I like it is I pull the fraction to the outside, which is the 1/3, right? The fraction is 1/3, right? That's going to be my radical. And what stays inside? This is the way I like to do it. So that would be what? That would be the cubed root. Isn't this 1/3 mean a cubed radical with a 3 like that? The cubed root of what? X squared. That's the way I like to do it. But can you tell me, once you have this one, can you give me another equivalent form? Who can tell me the other equivalent form of this? Well, instead of this power of 2 being on the inside, how would you write it? Not on the inside, that would be the cubed root of x, and then the whole thing what? Parentheses what? See, the squared would be out here. That's what I'm telling you. That's like the little tricky thing about this. Okay, let's do another one. Number 2. That was an easy one. Okay, number 2. What about this? What about 2x uh, 6, 7. Well, I like to see what the radical is. What is the radical here? Pull that off to the outside. This is 2x 6, so that means that the radical is the what? Oh, did I do it right? Yeah, that's right. This is the 1/7, right? The 1/7 is the radical, so that'll be what? The 7th root of what? 2x 6, like this. This is one way to do it. This is one form that you'll see. But you have to also know what's another acceptable answer and the other acceptable form. Or, what's the other way? Here they got the 6 here. What's the other way to write it?
Or 7 root 2x and then you have 6 on the outside.
Correct. And that's when they do this. But now, since the 6 is on the outside, that's when you got to put what? Yeah, see, it looks different, but it's really the same. That's what I wanted to clarify. See, that's what I wanted to do. So you see this, and you see this, and it looks like two different things. It's kind of really not, okay? We're good? Is that sinking in a little bit? Last one? Last one like this, number 3. Okay. I mean, it's just more of the same, right? Bless you. 10 m all to the power of 8 over 5. So this is an exponential form. You're going to write it in radical form. Which part of this is the radical part?
5.
Well, yeah, the 5, but it's really 1/5, right? Because the 5's on the bottom. It's really the 1/5, yeah. So I know this is 10m8. And then the 5 is this part, right? Some of you can just go straight to that. I know that you once you get it, you can just go to that, right? You guys agree that? You take out the 1/5, so that's your 5th root right there, like that. You guys agree? Yeah, that's one acceptable answer. But what's the other one? What's the other one? The 5th root of 10m. But now this 8 here, instead of inside, it's outside. So that's why they got to put this big parentheses on the outside like that. Correct. Okay. So if you need to watch those videos again from yesterday, okay, watch them again. And then I just did this one here, so let me stop it now.